Hello, and welcome to another episode of Hacking with Friends. Today I have our production gremlin Michael here, along with myself, Kody Kinsey, and we are going to be checking out a really interesting tool that focuses on something we all use, which is routers and Internet of Things devices.
Sounds pretty cool.
Yeah, so what are some common things you think of when you think about Internet of Things devices?
Like Nest, Google Home, Amazon Alexa, basically like all of the smart home stuff, which seems to be like everywhere now. Like it didn't quite take off the way they thought it would, but it's still like slowly creeping in everywhere.
4 of these light bulbs are connected to Wi-Fi. So, I mean, it really is kind of everywhere. Although not everything has Wi-Fi in it yet, but all these things are starting to become connected and smart.
Just a matter of time, really.
Yeah. And what do you think about when you think of the passwords that are set on these devices?
I think they usually are... They need to be as easy as possible, usually because with IoT products, often like it's hard to build like an interface to get them connected to Wi-Fi. So they have to generate our own hotspot or something like that. In fact, there was like really cool products like the electric amp where it was like trying to use LED blinks to communicate the password back and forth. And,
I've actually never heard of that.
And so I don't remember the details, but yeah, so that was a real problem. And then also like just oftentimes the microcontrollers on them don't have enough horsepower to make really good encryption keys and stuff like that. So that can be very limiting on like the passwords and key exchanges they can use. And then also like there's the hurdle of users. Like if you need to type in a password to get it connected, you know, password 123 is a heck of a lot easier to remember than some 10-character string. Yeah.
And then you also have support. So if you have, let's say, 1 million people who all buy this product, let's say it's a light bulb. Well, first of all, there's no screen. So as Michael said, it's already kind of challenging to put the password in there to connect it to your Wi-Fi. So they have to be creative with it. But then like if you have an individual password for every single light bulb, like every person who has a problem that goes online to find support, they're just gonna be like, what's the password? And if it's different for every individual user, it just makes it harder to offer support. Some people have been smarter and maybe put like on a label on the packaging, but then if you lose the packaging, then how do you get into the light bulb? It's just an interesting problem. And of course, as Michael mentioned, a lot of the times these use very simple default passwords. And there's lots of ways we can go after this. But another Internet of Things device that people don't often consider in this category is routers, because they think that they're kind of in a class of their own. But no, routers are just as vulnerable to this, because often they're given to you by a company that's giving you internet, and you might not have any control over the way it's initially set up. Like some nerds like to buy their own routers and then have total control over them. That's cool. That means that they have an advantage in this case because they get to go through and tick the settings and actually look the stuff up one time and make sure everything's set up properly. But if you just get a router delivered to your house, you're probably going to go in, maybe change a couple things, change the password to the Wi-Fi.
I think that's a little optimistic, really. I think the majority of people, when they get a router from their ISP, they plug it in, they're like, yay, I can connect to the internet. They don't even touch they don't even probably realize there's an administration panel that they have access to.
Right. So what we're talking about today is different from what I'm usually talking about. Usually I'm talking about breaking into Wi-Fi or hacking into Wi-Fi. Today we're going to be talking about what happens when we're already inside the network, or if someone gives us the password, or if it's an open network that doesn't restrict us to our own subnet so we can scan around and see stuff. We're basically going to be showing what happens when we have access to a network and we're able to get into the administrator account or the SSH account or the telnet account of an Internet of Things device like a router. So that means that when you got this router from whatever internet service provider, you plug it in and it has whatever settings they decided to put on it. And that might not be the best settings. They don't always pay careful attention to this. So if, for example, the password is password or the login is admin, it's probably the same for every single router that was delivered to every single customer. So if you just go online and Google default password and then whatever brand your router is, there's probably one that all of them ship with, unless it's a newer one that forces you to create a password the first time it's set up. So
I've never seen that.
I have. It's very annoying. As someone who's trying to do privilege escalation, like during like a red team, like it's just kind of annoying to find the router. But it's also very funny to find that a lot of the time, the password will be derived from like the MAC address, which anybody can see just by sniffing the Wi-Fi in the area. So a lot of the times there's really bad security built into these routers because of the way they're set up. by whoever provides them.
Why would they do it off a MAC address? Is it like they need a technical support to be able to come up with the password to help people? Because I can imagine like people messing themselves
I
up.
think I have many theories. My laziness theory, which is usually correct when it comes to people in coding, is that they needed to have like a seed for the password that was unique to each device. So they're just like, I'm so smart. I'm going to make it this device's MAC address, unaware perhaps that this was then going to be broadcasted in plain text, like to anybody in range, thus giving away. They're just like, well, they won't know it's derived from the MAC address. Therefore, they'll never figure it out. But then as soon as the method behind that was known, it became a lot easier to guess what those passwords were going to be.
Because obscurity is the best security.
Yes. Yeah. No. So I know some of our younger fans who have sporadic access to the internet have reported back to me that yes, there are a lot of Wi-Fi networks out there that by default use really easy to identify default passwords that are often derived from MAC addresses, like maybe just a really easy string plus the last part of the MAC address. So a word mangler is something that can very easily brute force passwords like that if the method is known. So it's pretty cool to know that, there's people out there who are able to get into Wi-Fi when they need it just because there's these gaping flaws that internet service providers have kind of baked into their products.
Yeah, that's something I've always actually wondered. Not necessarily with the admin password, but with the password, the default generated password for a lot of the ISP routers. It's often like 2 words and a 4-digit number, or there's always like a pattern. I've wondered if you could generate a specific word list for each ISP that has that exact formula, and like if you could maybe get a hold of like the dictionary they use of words to generate their passwords and make your own custom word list to brute force those Wi-Fi passwords when you capture a handshake.
Well, just by knowing the format of the passwords, you eliminate a huge amount of possibilities. Absolutely. So that's already something. But I imagine they would probably pick a rule set that has like a huge amount of results and then just pick randomly from it. So it would probably be pretty big key space, but at the same time,
still much smaller than any other key space.
Exactly. Much smaller than a completely random key set, or just actually really brute forcing it. So, once we know that, then we don't actually have to brute force it. And really, if you want to look up the result of having a bunch of default passwords, look up the Mirai bot, and you'll see that the botnets can really get huge when there's a bunch of devices out there relying on known default passwords that are exposed to the internet. As soon as someone figures that out, they can build a bot that takes over all those devices and does a ton of interesting stuff. So today we're going to take a look at a program that takes the first step of exploitation after you get into a network. And this could be an Ethernet network or a Wi-Fi network. But what it's going to do is basically audit all of the Internet of Things devices on the network. We're going to find hopefully a couple vulnerabilities, and we're going to try to exploit some of them. So this is a bit more heavy than just the Wi-Fi hacking, getting access to internet stuff. This is going to go a step further and show why it's so dangerous to give someone your Wi-Fi password, because anybody can actually do this. You used to be able to do it on an Android phone. I haven't tried it recently. I may have to try it again and see if it works.
Yeah, let us know in the comments if you want us to do that on the next live stream, or maybe later.
Oh yeah, we could try an Android one. That would
be really fun.
Difficult to record, but we'll try it, guys. We'll try it. Just
make my job harder and harder every time.
Yeah. All right, well, let's take a look at my screen. And this is the tool we're going to go through today. It's called Routersploit. And this is a tool I've been using for quite some time. I love it because it's very similar to Metasploit. You can tell by the name probably. But also the format is really familiar to anyone who's ever used Metasploit, where it's basically a big collection of modules and stuff that makes it possible to very quickly go from, I didn't click it for a while. Go from step to step to step and set myself up to be able to discover something, attack it, and then move on to the next step of exploitation.
Okay. Yeah, and so despite the name Routersploit, it does work on like all IoT devices.
Yeah, so this is Python, which I really like. It's been updated to Python 3, I believe. I'm pretty sure. Okay. And if I go down to some of the documentation here on the GitHub, there's a lot of documentation, which is nice. Yeah. There's not even. No, they have a whole separate webpage.
Is there a whole wiki?
On Threat9, yeah. So they have a lot of documentation on how to use this. It's really, really straightforward. But Michael's right. It's also going up against cameras, going up against pretty much any IoT device you can think of that has known exploits available for it. So another thing I like about this is it's kind of like single purpose. It's like IoT devices and just that. So if you're looking at auditing IoT devices, this is a really good place to get started. Although I did note that it hasn't been updated since 2019. So if you're the developer, we'll give you more attention if you keep updating this.
So it allows you to be a little more surgical about like what you're attacking than maybe just like port scanning the entire network and then like just blasting everything.
Well, I mean, okay, so let's say that you're someone who wants to get into the router. You have a couple of options. You can try a brute forcing tool like Hydra or whatever that's going to take some setting up and configuration, but is going to go after that router and attack it once you know that it's the router and once you know that it's vulnerable. And it might not be vulnerable. It might have a crazy long non-default password you're never going to get. You just don't really know. You can scan the entire network and then attack everything and hope that something is vulnerable to something. But really what makes more sense is classifying the devices like, okay, this is an IoT device, like it's connected over Wi-Fi. Let's run a bunch of common tests to see if it's vulnerable for any of these known exploits. And if it is, then it warrants further investigation. So our process will be, we'll scan a network, we'll find some interesting targets, we will point Routersploit at it and do the autopwn.
Thank you.
Yeah, sorry.
It made me cringe last time.
And what's cool about this is it's going to go through every single iteration of these exploits and attempt to just see whether or not it's vulnerable. And then it'll tell us what vulnerability is there and what module corresponds with it. So if this is ringing any bells with Metasploit, if you've used that, it's a very similar process. So we scan to identify a vulnerability, we find a vulnerability, we then would like build a payload and deploy it. So in this case, what we're going to do is we're going to try to get a foothold on the device by running the exploit module, and then we'll try to run a payload in order to get more persistent control or elevate our privileges. In this case, we're not going to go too much further than that because I know the systems we're trying this on and it's not going to let us go too much further. But in a device that is vulnerable, I have seen this work and be able to give you like a remote shell or otherwise have remote control over a device that is vulnerable. So I do need to mention that, of course, if you're on a network that is not yours and these devices aren't yours, breaking into them when they require a password is a crime. So it's really...
Always have permission, kids.
Yeah, so it's really important to note that this is one of those tools that can get you in trouble if you're just using it left and right. Eventually, someone may catch you trying to get into a system that's really important and is heavily monitored. So just please note that this is not a quiet attack, and while it is very effective for auditing, it also runs every possible exploit known against IoT devices that has been compiled here against your target. So if that target is protected or monitored, it's going to create a lot of noise. So you really do need to be careful here and make sure that you have permission to run this against any device you're trying to break into.
So this is going to leave some kind of evidence in the logs of the router then?
Yeah,
that you can go and look at?
Yeah, basically. So multiple things. So if you're monitoring the network at large, this is going to create suspicious behavior.
So like Wireshark or something?
Well, or like a intrusion detection system or yeah, something like that. But also if you are just taking a look at the router later, yes, it is definitely going to leave logs from your MAC address. So unless you've randomized it and there's other things that like the timestamp that could like lead someone to discover like who you were or what you were doing. It's really just a bad idea to use an attack like this in public without making sure that you have permission to do it. So, all right. So as you can see, there's installation instructions. I'm running Kali Linux, which is a really good place to start with this. But if you're running Ubuntu or Mac OS, there are actually installation guides for this too. Also Docker, but I hate that. So in order to go ahead with the next step, we're going to go and take, the installation guide for Kali Linux. And the first is to make sure that we have Python pip.
Okay.
So I'm going to go into a terminal window. And then I'm going to enlarge it a bit. And I'm just going to paste this instruction in. And it's going to make sure that I have Python 3 and Python pip so I can install the rest of it. I'm going to do a git clone. And I've actually already done this step, so I'm going to skip to the next one. I'm going to do a cd Routersploit.
If you can hear our cat in the background.
All right, apologies. And then we're going to run Python 3 So after that, we change directory into the downloaded Routersploit directory. Then we'll run Python 3, tac m, pip install tac r requirements.txt.
So this is just installing like all those extra libraries that it's gonna use.
Yes, exactly.
Okay.
I already did this, so everything is installed. And then the last step here is just to run python 3 rsf.py.
And
Cool.
would anyone ever need to run like sudo or something like that? If you do ever have problems, always try sudo.
Yes.
Permission denied.
Well, yeah.
It's pretty
so
common.
you're not supposed to, for some reason, you're not supposed to sudo like pip installs for some reason. So try it without it if you don't need it.
Yeah.
But if it doesn't work, then often sudo will fix it. It just might mess up your Python
Install. Yeah,
install
I think I've done that to myself once or twice.
All right. So here you can see we have the Routersploit splash page. I'm also going to.
That's a bit of a disappointing splash page. Like,
I agree that there could be more ASCII art, but they're keeping it serious. It looks, So Threat 9, it looks like the author is. I don't know if that was always the author, but now it is. Oh, and there's a beta program. Cool. Maybe it was updated more recently.
Yeah.
So if I type help, you can see the basic syntax we're going to be using here. Use module, exec, shell command, args, search terms, and then exit. So if I, for example, want to search SSH, that'll give me a list of all the different modules that contain SSH. And that also is divided by which manufacturer is being targeted here. GeoVision, Canon, D-Link. These probably sound pretty familiar if you're used to...
Canon? Isn't that just a camera company though? Like
No.
No? Okay.
No, Canon makes a ton of random stuff.
Interesting.
Yeah. You would be amazed. It's just like how Daewoo also makes like machine guns.
Okay.
And like refrigerators.
Because reasons.
Yeah, exactly. They make like trucks, machine guns, and refrigerators, and like everything else you can think of.
Yeah.
It's just like one of those companies that makes a lot of stuff. I don't think Canon makes machine guns, but if they did, they would have a great brand.
Yeah.
Anyway, so we have a bunch of...
I was gonna say like Hack Vision up there. I think I saw.
Yeah.
That's a big Chinese.
Juniper. That's like what the military uses. That's great. Belkin, Cisco, Netgear. You guys have heard of these. All right.
Yeah.
So like we have enough information about maybe which of these would be useful once we find something, but we haven't really found anything yet. So let's take a look at what I can find.
And to be clear, like all the ISP, the internet service providers, they don't really make their own equipment, right? They buy it from OEM like Cisco or Microtech or Netgear or someone like that, right? I think some of the largest ones like Comcast might, but I'm not 100% sure about that.
Okay, so first thing I need to do is get my network range. That means I need to know what all the possible IP addresses are in the range that I want to scan. So I'm going to run ifconfig to get my current IP address.
Do we need to shift away from that?
I don't care. I mean, if let's see, wait. If I mean, I guess I could just sudo root. I mean, it doesn't matter because as soon as I change this, then...
Okay.
All right, cool. So now I have a random MAC address, but you guys just saw it anyway, so it doesn't matter. So what I'm going to do is run ifconfig, and I'm going to grep inet, and that should give me... Oh, it didn't even show the MAC address, so it was unnecessary. So that gives me my IP address on the network. Cool. So this, if I want to be really, really lazy, then I can go ahead and run ipcalc.
What's that do?
It gives me a calculation of my net mask, the network wildcard, the network range, the host minimum, which is usually where the router is located, the host maximum, so that's the highest IP address in the range, the broadcast network range, and then also how many hosts are available on this network. So if this was like a different, and it also tells me what type of class this network is. So it's a Class C private network. So if I were to run like my internet service provider's IP address or something, then it would it would be a different class, and there would be like a huge amount of hosts that were available, and our scan would take way longer.
Yeah.
So it's important to calculate this, because if you haven't been to networking school, or if you're just lazy, then knowing how to come up with this number on an IP address that has like an unusual range you haven't seen before is just as simple as doing this if you just want to get started with the tool. I love this little hack because it's just like easy. I know how to calculate a network range. It's not hard, but like it's still just useful.
Right.
So all right, now we know our network range, and now I can also do a scan. So I want to do. I don't need to.
So the tool doesn't automatically do that. Like I would think you should just be able to like type scan or something like that.
Oh yeah, that'd be great, but no, it doesn't. You have to have a target already, and in this case, for it to work, we're going to search for port 80. So we're going to look for something that's offering like some sort of web interface.
Okay.
And we're also going to...
and it's pretty common for a router to have a web interface. That's usually how you interact with it, would be going to local IP address, like 192.168.1.1 or 10.0.0.1.
All right, so here I have a command, nmap tacp80, so port 80. The network range, and then -- open. So that just says, I don't want to see any scan results that aren't open on port 80 in this network range. And it's going to check everything. And instead of giving me a complete list of everything on the entire network range that exists, plus whether or not it has port 80 open, it's just going to return the ones that do have port 80 open.
Yeah.
All right, so we have a couple ones. Let's see. 254, and then... Oh yeah, I guess, is that it? Wait. All right, so this is the first one we're going to focus on, right here. And this is going to be our first target. So what we're going to run first, so back up in Routersploit, I have a split screen here. I'm going to, what is it? Use scanner, auto, there we go. Okay, so once we have this selected, we are inside the module, and I can type show info. Wait, yeah, okay, cool. So this tells us information of, about everything. Okay, well, I didn't want that. So we're in this module, show options. Shows way less information, but way more pertinent information about this module. I'm gonna run it again. There. Okay, so we can see we have some mandatory options that we have to set, like the target, and then we have a bunch of optional ones, which are kind of auto-filled in. This is the number of threads we're running at the same time, whether we're using Telnet, all this cool stuff. So let's say that we want to now target the router. So we'll type set target, and then we'll paste in the target, and then show options. And now you see the target is filled in.
Oh, cool.
Okay, so next we can type execute. Okay, exec. Okay, how about just run?
Run, nice. It would be nice if it were a little more automated, maybe.
I mean, you write a framework for attacking.
Oh, no, yeah, this is super awesome. Don't get me wrong.
So it's just like the whole point of like identifying something and then like with Nmap or something more stealthy and then launching like every single missile that has ever been invented for an IoT device at it is just like a little bit of subtlety and also speed. So this is going to take a while to actually go through all these exploits. And it's just trying like thing after thing after thing after thing after thing. If we wanted to be smart about this, we would like kind of ferret out like what the manufacturer was by looking at the MAC address.
Oh, so it doesn't do that already?
What do you mean?
It's just so it doesn't say like, okay, this
I hit the auto button.
Okay.
I mean, if you really want to have a nuanced pay, like, you know, like all the way through and like scanning and like trying, like, yeah, you can do that. But if you want to quickly smash through like the defenses of an IoT device during a pen test, and you don't really care about, you know, being the most like subtle guy in the world, then you select the one that looks like it could be interesting, like the router in this case, or something that's offering up a port 80. And that's a fairly like low key scan to run. And then we would do something like this. So look at this. We have a device that is vulnerable. And lucky enough, it's my device. Oh, great. So you can see that the exploit is even proposed here. And we have a whole bunch of other vulnerabilities that couldn't be exploited or that couldn't be verified. So it might actually still be vulnerable to this. We don't actually know. But in this case, we're still getting a result that's telling us like it might be, you can try it. So if we want to be thorough, we would just go through and try each one of these and see if it works. Okay. So let's try.
How would we do that?
Let's try this one. So we'll, so most importantly, we can see here, we have indications that a test has come back positive and this device is vulnerable. So it also tells us the exploit associated with that. But let's go ahead and test one of these ones that couldn't be verified in order to see whether or not it works. So we'll type use module, and then we'll just paste in this. I think I just have to get rid of the module. Yeah, so we'll just type use and then the path to the module.
Okay.
There we go, and we can see this has changed. So I can type show options. And we can see everything is filled in except for the target. So we'll need to set target. Let's see. Oh no, I have to go back and copy it again. No, wait, it's just in, where did I put it? Oh, it's here, it's down here.
It's hiding from you up there.
There it is. Set target this, run, and we'll see if it works. Exploit failed, telnet connection error. Bummer, connection refused. Okay, so that one didn't work.
Yeah.
But we kind of expected that because we couldn't say whether or not it was one of the ones that was working to begin with. But if we want to be a thorough hacker, then we can do that. All right, so let's take this one we know does work. I'm going to type use and then the path to the exploit. Okay. And now I can type show options. And we have a couple things to fill in here. We have the target, actually, yeah, and everything else is auto-filled in. So SSL false, port 80, verbosity true, target architecture. Okay, and it's identified like what type of architecture it's using.
That seems useful. Set
Target, and then we'll paste it again. No, we'll paste, I'll just type it, I can see it. 192.168.254.254. Show options to confirm. Run. Running module exploits blah blah blah. Target is vulnerable. Invoking command loop. It is blind command injection. Response is not available. So what does that mean?
It didn't work?
No, it did work. But
Wait.
What is a blind command injection? If you had to guess from context. Please.
Oh, you mean like we can run commands, but we can't see like the output?
Exactly. So this means that we can execute commands on the router, but we can't see a response. So basically, this vulnerability allows us to execute a command on the router without any permission or even knowing the password, but it doesn't allow us to see what's going on. So the next step here would be trying to find another way to escalate our permission. So if I was a big time serious hacker, I would double down, find this model of router and be like, all right, I'm in. Let's see what I can do. I would look at the user manual. I would look at other exploits that had been targeted at this model. I would look at the default credentials. I would basically start finding out how I can expand my foothold in here. But if I'm not a smart guy and I just want to try the next obvious step, let's see what's going to happen. So we can type, well, here, the very last part is welcome to command. Commands are sent to the target via the execute method. For further exploitation, use show payloads and set payload commands. So let's type show payloads.
Show
payloads. All right, so here we can see different options for how we can escalate our privileges on this device, which is pretty cool. So any idea what a bind TCP shell is?
Are you like trying to run a shell through the TCP? Yeah, I don't remember what TCP is.
So there's two options here. There's a an interactive TCP bind shell and an interactive TCP reverse shell.
Okay.
Yeah. So the reverse shell basically tells the router, hey, I want you to call back on this port and start a session and basically allow it to administer the router. So that's basically taking our ability to inject a command into the router to say, hey, here's a great idea, router. By the way, this is your idea. Go ahead and connect back to this computer that's evil and allow it to administer your system. That way we can see what's going on when we type our commands. Because right now I can type something and I have no idea if it's actually going to run or not. I would need to use the execute command and then whatever command I want to run. And if I've looked at the router and I figured out what the commands are to make it do something, then, after reading the manual, I could probably make it do something without necessarily needing to see feedback. But if I want to be able to get it to connect back to me, or if I want to be able to connect directly to it by having it open up a port or something, then I need to maybe use one of these payloads or just make my own if I know how to administer this device. Because basically I now am the administrator of this device and I can start to make it do stuff that it wasn't supposed to do, even though I don't have the password. So I'm going to, let's go ahead and do the reverse TCP.
Okay.
And set payload. Show options. And all right, now we can see we have a number of different options. One that is blank here is the encoder. So if we want to see more information, we can type show encoders.
And what's an encoder in this context?
An encoder would be something to hide the communication or encode the communication so it's not in plain text.
Okay, so like encrypting it?
Yeah, so encrypting it or base64ing it or something like that. In this case, if you type show encoders or show encoder, and you don't get anything back, it means that there might not be any encoders available for that payload. That's gotcha. What their webpage says anyway. So all right, so we have one setting that does need to be adjusted here, and it's the lhost. And this is the connect back IP address. Now, if we were to use the other payload, set payload.
And so lhost is the host of your hacking machine.
So look at this one. We have rport, encoder, rhost, lhost, lport. So now there's like more. What is this? Okay, so lhost, what do you think that is?
Is that the hacking machine?
Yes, that's the local host. That's the attacker's computer. What is rhost?
Remote host.
Remote host. That's the victim computer.
Oh my, look at me, all smart.
Yeah, you're so good at that. All right.
Pro hacker here.
Yeah, so let's go ahead and we'll try this one first. I don't think either of them are going to work because I updated this router to fix this, even though it's still somewhat vulnerable.
Why would you do such a
Because
thing?
I use this. So, all right, so this is what's going to happen. First, let's type show encoder. There's none for this one either. So we'll type set lhost. And then I need to get my IP address. Fortunately, I just did that.
And so what would the purpose of running the encoder be? Is just
to hide the communications and just make it so that it doesn't immediately show you running a bunch of malicious commands unencrypted over the network.
So maybe you're a little less obvious to anyone that might be monitoring the network or anything that might be monitoring.
Well, it won't be flagged. It won't be flagged as a backdoor because there's a lot of intrusion detection systems that are they're going to see a command to establish a backdoor by some sketchy means. They're going to be like, what is this? So let's set lhost. We'll set rhost. Where did I get that? Oh, it's just up here somewhere. Yeah, it's right here. All right. And then show options. Okay, so everything is filled in except for the encoder. So now we should be able to run this payload. And if it works, then we'll get a shell back to us that allows us to get more of an interactive ability to communicate with this device. Using wget method, using wget to download binary. So apparently this runs by being able to do a wget command on the device, download something, and then have it run. So as you can see, it failed to transfer the payload. And that's because, again, I updated this because before it was working and that wasn't good. But if this had worked, then, well, actually, let's go ahead and show the other one. Maybe the other one still works. I don't know for sure. So this is the bind TCP. What if we wanted to do a reverse TCP? Do you know what the difference between a bind shell and a reverse shell is?
No.
So a reverse shell is when we tell the target to call us back. Okay.
Yeah. But what? Okay, that I kind of knew. But the bind shell, what are you binding it to?
The attacker's computer. That's why we need our IP address, their IP address, and because basically we need to know what they're calling back to, or rather,
how is that different from a reverse shell?
Because we're connecting to them rather than them connecting to us.
Gotcha.
So show options. I'm going to set L host to be whatever I am. What was it? 84. And then run. So this is the process that you will go through if you're using Routersploit to attack a system that, of course, you have permission to that is vulnerable. You'll use a payload in order to get more of a foothold. Or again, you could just go ahead and look up commands on this router and figure out how to administer it without relying on some of these fancy pre-configured payloads. Yeah. So if you're interested in this sort of thing, I'm going to cut us off there because we don't have too much time on this stream. But if you're interested in this sort of thing, I highly recommend you check out Routersploit. Audit your router. Make sure you don't have default credentials. In fact, another attack from this that I wish we could run. Let me just see. Hold on. Oh wait, no, that's in the wrong. It's in the wrong shell. So I'm going to run a quick ARP scan. I'm going to see. Yeah, I'm 83. That's too bad. All right, if you want to test out this tool, I highly recommend you guys you try out Metasploitable. We had a virtual machine up earlier. I don't have time to set it up again now, but you can try this out on Metasploitable and see how it is able to figure out default credentials. If you use the exact same commands that we showed today in order to assess the general vulnerabilities of the device, what's really cool about Routersploit is it will also scan for OpenSSH and Telnet, and it will figure out if it's using if those ports are using a default credential. So I really like this because it allows you to very quickly audit a device that's using default credentials, and Metasploitable is perfect for showing that off. So if you're curious about this and you want to try it out, you try it out on your router and it doesn't do anything, well, you can get some good positive results from running Metasploitable in a virtual machine, which is a really cool, deliberately vulnerable virtual machine that allows you to test this stuff out and actually find real vulnerabilities and learn from them.
I was going to say that sounds like a really good way to practice at home, without breaking any laws, like, being completely ethical. And then hopefully those are the skills you would be able to develop to get a job as a pen tester or blue team, red team, something like that.
Yep, exactly. And it'll also enable you to discover like what could happen if a router actually finds a flaw like this on your system. If you're just curious about this stuff, it doesn't take that long to set it up and
lock your stuff down.
Yeah, and feel like a hacker, because we can guarantee if you run Routersploit, if you run Metasploitable, you will find some vulnerabilities, at the very least default credentials. So it'll show you what it looks like when you find a real vulnerable device out in the wild. And I will tell you from doing this in the wild, they are out there everywhere in places you wouldn't expect. So just make sure that you're not breaking into devices you're not supposed to, because that will get you in trouble.
Now, if your system did get compromised, it sounds like that's the perfect lead into our sponsor.
Of course, Michael. So our sponsor, as always, is Varonis. And if we terrified you today into worrying that hackers are getting into your network, well, they probably are. But fortunately, there are solutions where you can catch hackers as soon as they do anything malicious or suspicious, and Varonis is one of the best out there for that. So if you're curious about how hackers like me can get stopped when they break into networks, then check out Varonis. In particular, I recommend checking out the Cyber Attack Lab. It is a great example of how you can shut down hackers who manage to break in.
And we even have a code for that, right? The sign up for...
Oh, that's right. Well, actually, if you guys want to check out a great class on PowerShell, we also have a PowerShell class that we will drop a link. It is a really good way to get started with learning how PowerShell works in an organization, because a lot of the attacks we talked about today are results of misconfigurations of Windows stuff.
Windows Server.
Windows Server. So if you don't want to have a vulnerable Windows Server, and if you want to learn how PowerShell works in order to develop some interesting skills around administration and keeping these sorts of things safe, check it out, because it's an amazing resource, and we will include a direct link in the description with a unlock code.
Awesome. Yeah. Sounds fun.
Cool.
Thanks for joining us.
Yeah. Well, thank you for joining us another episode of Hacking with Friends. Michael here is rapidly getting started with co-hosting, and I really appreciate him jumping in and covering some of these interesting topics like Routersploit. So Yeah, if you like this content, make sure to check out the YouTube channel
Mhm.
at youtube.com/c/securityforward, SecurityFWD. We have all of these archived there, so you can always check them out if you liked it. And yeah, we hope to see you next time.
Don't forget to like and comment on the videos, and then also click that notification bell, because that's what will help you get notified when we go live in the future. We also schedule them. We do them on Tuesday and Friday every week.
That's true.
So
every week.
Stay tuned.
Stay tuned. All right. Thank you.
Bye.
This guy's a YouTuber. Bye.